All right, so here we are, 8.3, which is technically the second part of 8.2. So we're going to be looking at conditional probabilities. So there may be times when the probability of one event is influenced by another event having happened. So you could think about this in sports. A big example is for those who are sports nerds like me, that they look at the probability that like ESPN puts throughout a game. So what basically that is that they're calculating the probability of one team winning, knowing what has already happened. So basically, I'm looking at the Minnesota Wild versus the Las Vegas Kings hockey game. So the Wild are up 2-1, 7 minutes left in the second period. So if I look down here, what? Doesn't have it for hockey? Well, that's weird. But so sometimes it has it on here where it has like their winning probability. And so it'll say like their chance of winning is 25% or 58% or something like that. So that's just saying that knowing that all these events, that knowing that the Wild are up 2-1, what's their probability of winning? Okay, so that's conditional probability. So knowing that one event has happened is called conditional probability. Okay, and the way we write this is where we'd have like our P of A, which will be whatever event we want, and then we do one of the absolute value lines, B. And when we see this notation, we read it as if it's the probability of A given B. So basically, knowing that B has already happened, what's the probability of A happening? Okay, so if you think about maybe going back to our first homework, our Settlers of Catan problem, knowing, or Catan, however you want to say it, knowing that we've rolled a 2, what's our probability of rolling a 3? Or different things like that. I'm going to use a deck of cards. I think this is very helpful to be able to see. So let's do some normal probabilities real quick. So there's 52 cards in a deck. So knowing that, what's our probability of picking red? So if we did probability of red, we know it's out of 52. And we could count, so there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 hearts. And so there's the same amount of diamonds. So it would be 26 out of 52, or 1/2, which is 50%. And this is just saying, like, what's my probability, if I just pick one random card from a deck, what's my probability of picking a red? Okay? And then probability of hearts, so this is still out of 52. And then our probability of hearts. So we just counted that there's 13 hearts. So it'd be 13 out of 52, or 1/4, which is 25%. Okay? Those were just normal probabilities. Now what we want to do is we want to look at conditional probabilities. So this first one, probability of king, we would read this probability of king given red. Okay, so we know that red has already happened. So we know our card is red. So how many total red cards were there? Well, from probability of red, we saw there were 26. So now our total that this could be out of is out of 26. Okay, and now we got to count how many kings there are that are red. So there's the king of hearts. I'm not sure if you can see that. And then there's the king of diamonds. So there's 2. So this probability would be 2 out of 26, or 1 out of 13, which is, if we did our percentage, 7.69%. Okay, And so now the probability of a space, that typo, supposed to be a probability of a spade given black. Okay, so if there's 52 cards in the deck, 26 are red, that means that 26 are black, so we know that we are picking from one of those 26. We know that the card is black. And then we would have to look at what's the probability of picking a spade. So just as with hearts there were 13 cards, there's 13 spades, and so that would be 13 out of 26, or 1/2, which is equal to 50%. Okay. Now, probability of face given diamond. So we know that we picked a diamond. So for each suit, there's 13. So we know this is going to be out of 13. So then we got to look at a probability of a face. So our face cards, or we can think of them as our royal cards, are our jack, queen, king, but then also aces would be included in face cards. So for our diamonds, our face cards, we have the ace, which is 1. We have our jack, 2. We have our queen, 3. And then our king, 4. So our probability would be 4 out of 13, or 30.77%. Okay, and now we want to look at probability of picking an ace given it's a face card. So knowing that the card's a face card, what's our probability of getting an ace? So first off, we need to look and see how many face cards there are. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then remember we got the aces. So we got 12, 13, 14, 15, 16. So our probability would be out of 16. Then we got to look at how many aces there are. So for aces, there's 1, 2, 3, 4. So our probability would be 4 out of 16, or 1/4, which would be 25%. Okay, so that's using a deck of cards. So hopefully that starts to make sense. So probability, basically what we're just doing is we're limiting down our options of our total possibilities because we know something's already happened. So let's look at another example with this. So here we have some data. So we have our two-way table. So of people with GPAs less than 2, between 2 and 3, and then greater than 3. And then basically they polled them and asked, did you skip many classes, did you skip few classes, or did you skip, so just many or few. Okay, so here we got some probabilities. So what is the probability a student has a GPA between 2.0 and 3.0? So basically this would be probability of 2.0 to 3.0. And our total is 1,000, so this would be out of 1,000. And the total number of students that are between a 2.0 and a 3.0 would be 4.75, or 475. Okay, and then we could simplify that down. So we'd get 95 out of 200. We could do that even more. Get 19 out of, I believe, 20, or 19 out of 40, which would be the same as 47.5%. Okay. And so then B, what is the probability that a student has a GPA under 2.0 and has skipped many classes? So that would be probability of of less than 2.0 and many. So our total still is out of 1,000 because we're not using any conditional probability. But then our total of 2.0 and skipped many classes, or less than 2.0 and skipped many classes, is 80. So this would be, gotta get back to my pencil, be 80 out of 100, or 80 out of 1,000, or 8 out of 100, which is 8%. Okay, and so then we keep on going. What is the probability that a student has a GPA under 2.0? So probability of less than 2.0, or, that's my dog, probably wanting out. I'll get her out in just a second. Or has skipped many classes. So, or many. So now our total is still out of 1,000. So then we got to look at the total number who have less than a 2.0, which is 255. So we got to add 255 to the amount that have skipped many, which is 110. So that gives us 365. Hey, the amount of days in a year. But remember that 225 adds up those ones, and the many adds up these guys. So, switching to red here, this 80 is being counted twice. So now from our 365, we have to subtract 80. So we would get 285 out of 1,000, which would be out of 200, let's see, 285 divided by 5, be 57 out of 200, or 28.5%. Let's box these. Okay, what is the probability that a student's GPA is under 2.0 and they didn't skip many classes? Okay, so probability of less than 2.0 and they didn't skip many classes, so they skipped few. So still out of 1,000. So we'd have to do, let me clean up my table. I didn't want to copy that. So we got to add up the less than 2.0, which is 255. And we got to add up the number of few classes, which is 890. So we'd have 255 plus 890, which is equal to 1,145. Which we can see on this one, obviously we have a problem because we can't have a probability more than 100. So with that, we counted our less than 2.0. Then we also did those who skipped few. So we're overlapping the 175, so now we have to subtract 175, which would give us, I believe, 930, but I'm just going to check, or 970. That's right, so we get 970. So that would give us 97 out of 100, which is the same as 97%. 10%. Okay, these last two we'll do real quick. What is the probability that a student has a GPA under 2.0? So probability less than 2.0, given the fact they skipped many classes. So given that they skipped many. So now our total is not going to be the 1,000. Our total is going to be based off of what we're given, and we're given that they skipped many classes. So our new total is now 110. So this would be out of 110. And of those 110, how many of them had less than a 2.0? That would be 80. Because 80 of those with less than a 2.0 skipped many classes. So we'd have 80 out of 110, or 8 out of 11, which is, this is kind of a cool percentage, 72.72%. So that was our conditional probability. And now let's look at our last one. So what is the probability that a student skipped few classes? So probability of few, given the fact they had a GPA, not FPA, GPA, between 2.0 and 3.0. So given 2.0 to 3.0. So this changes our total again. So now we're given that it's between 2.0 and 3.0, so our total would be 475. So now our total is out of 475. And how many of those skipped few classes? That would be 450. So we'd have 450 out of 475. See what that reduces down to. It can reduce down to 90 out of 95, which could reduce down to 19. So we'd have 18 out of 19, which is the same as 94.74%. All right, so that's how we do those different probabilities. Go ahead, look at the homework, give it a try. If you're having problems, check out the other helpful videos on this lesson, or reach out to me and I'll see if I can help. Okay, see you guys.